This is a video on lesson 1.7, graphing absolute value functions. Before we get to absolute value functions, we need to understand what a parent graph is. A parent graph is the basic graph of a function. So for a basic linear function, y equals x, the parent graph looks like this. It has a slope of 1, and its y-intercept is at 0, 0. If we put plus 3 on that, it shifts everything in the graph up 3 spaces, including the y-intercept, which is now at 0, 3. If we have the graph x minus 2, that shifts everything from the center down 2 spaces. So every single point is down 2 spaces, and the y-intercept is at 0, negative 2. What happens if we put a minus sign in front of the parent graph is that it flips it over the x-axis. In this case, it makes the slope go down and to the right. This will make a little bit more sense flipping it over the x-axis when we look at some different kinds of functions. Let's take a look at the parent graph of a quadratic function. That would be y equals x squared. It makes this shape, which we'll learn later on, is called a parabola. The bottom of it is called the vertex, and once again, it's at 0, 0. Just like in our linear graph, if we put plus 3 beside it, that makes everything shift up 3 spaces. So now the vertex is at 0, 3, just like the y-intercept was. Everything in the parabola is the same, except everything is up 3 spaces. If we take the parent function and subtract 2 from it, that shifts everything down 2 spaces. And so going from the origin, that makes the vertex of this parabola 0, negative 2. If we put a minus in front of the parent function, it flips it over the x-axis, and so this parabola will open upside down, and its vertex stays the same at 0, 0, but now it is a maximum point, or the top of this graph. Here on the parent function, it was a minimum point, or the bottom of the graph. So now that we know that about parent graphs, let's take a look at an absolute value function graph. Remember that with absolute value, everything on the inside of the brackets will become positive. So if we have a negative x number on the inside, it will become positive. So this is what the graph of an absolute value function looks like with no alterations. The bottom of it, or the minimum point, is called the vertex. That's another word for corner, and it starts at 0, 0. So first we're going to look at what happens if we put a number on the outside of the bracket. So for the absolute value of x plus 3, everything shifts up 3, just like with the other two functions. If we put a minus 2 on the outside, that shifts everything down 2 spaces. So with plus 3, the vertex of this graph is at 0, 3, and for the negative 2, the vertex is at 0, negative 2. So the outside number shifts the graph either up with a positive number or down with a negative number, and the vertex affected is the y number, not the x number. Now we're going to take a look at what happens to an absolute value graph when we have a number on the inside of the bracket. So for this, y equals the absolute value of x plus 3. This time, the graph shifts to the left. And notice that the sign is different. Even though it's a plus 3 on the inside, our vertex is at minus 3, 0. So a positive sign will shift the graph to the left when it's on the inside of the bracket. And so for the minus sign, it will shift it to the right 2 spaces. So for this graph, the vertex is at 2, 0. So the inside number affects the x, the outside number affects the y. One more thing we need to take a look at is what happens to absolute value when we put a minus sign in front. Let me go back to this one. If I put a negative sign in front of this, it flips it upside down over the x-axis. That means this function opens down, and this vertex is now a maximum point. Before it was a minimum point because it was the bottom of the graph. So let's take a look at what happens with the blue graph. That will flip it upside down and put in a negative in this one. We'll again move it upside down. So that'll help you answer your questions on which way does the graph open, up or down, and if the vertex or the corner of it is a maximum point at the top or a minimum point at the bottom. Let's also take a look at what happens when we have a graph, when we have numbers on the outside and the inside. So for this first graph, from the parent function, the outside number means it goes up 3 spaces, and the inside number plus 2 means it goes to the left, and so this vertex is at -2, 3. Remember, with the inside number, it changes the sign either from positive to negative. It doesn't do that for the outside number. For this green graph, the -3 on the outside means the vertex goes down 3. The -2 on the inside means it goes to the right 2 spaces, and so the vertex is at 2, -3. The minus sign in front of this means that this graph opens down and the vertex is a maximum point. So now let's take a look at some of our problems that we have. For problem number 5, when comparing the graph of g of x and the equation of f of x is equal to minus the absolute value of x plus 4 minus 5, which function has a larger maximum? We're taking a look at this graph. This is the g of x picture that we have. We can tell that the maximum point is at -3 on the y-axis. So we're going to keep that -3 number in our head. We're going to type this into our Desmos calculator. So go to desmos.com. This is what it normally looks like. And so I'm going to type in f of x, and remember that means the same as y, equals minus the absolute value, that is the vertical line. You can find that key right above the enter key. You'll have to hit shift to get it. X plus 4, vertical line, minus 5. If this is hard to see on your screen, you can zoom out over here with the minus sign, right where the plus sign is. If you click on that point, it also tells you that it's at -4, -5. We're only looking for the y number, which is -5. Remember that over here, the g of x number at the top was -3. So this one has a larger maximum because it's at a higher point. So your answer here will be g of x, or g with an x in parentheses. Looking down here at the two problems that we have with absolute values on both sides, we're going to use the graphing calculator to solve this. We're going to treat the left side and the right side as two different graphs, and we're going to see where they intersect, and we're only looking for the x number. So let's go back to our Desmos calculator. I'll come back over here and type in y equals the absolute value of 2x minus 6. And then also type in y equals the absolute value of 4x plus 4. And remember, we're looking for the 2 points where it crosses, and we're looking for the x numbers. Now you can either zoom out or you can click and drag this downward. And we want to click on the 2 points where in this case, the red graph and the blue graph intersect. There's point 1 and there's point 2. So it first crosses at -5, and over here at 1/3. That would be the repeating 3. To type in 1/3 on Google Forms, you can type in 1/3. If you were to type in 0.333, I would understand what you put also. So that's your answer for that question, -5 and positive 1/3. Let's take a look at one more problem at the very end. The cost of shipping a 25-pound box with UPS is $25.50. If the weight of the box may vary or differ by no more than 3 pounds, what is the range of weights of a box that ships for $25.50? The cost actually has no effect on this problem. We're looking at how heavy the box can be. This is one of those cases where algebra actually complicates the problem. This is more of a common sense problem. It can vary or differ by no more than 3 pounds. That's up or down. So we have 3 pounds lighter than 25 pounds. That's going to be 22 pounds. And if it's 3 pounds heavier, it'll be 28. So the range of weights of the box is anywhere from 22 to 28 pounds. And you can just type in here 22 to 28. Now it asks us to upload a picture of the graph. So this is how to graph using this type of absolute value problem. The first thing we need to get is how it differs from the center weight, which is 25 pounds. So to type that in, you need y equals the absolute value of x minus 25. And you'll notice that that makes the graph go off to the right, so we can click and drag the graph over here. We need one more thing though. Since we can be off by 3 pounds, we need a line that says y equals 3, because that's our basic line that we need to get the intersection. And so this is a graph of the problem, and it gives us the two x values of 22 and 28, which we figured out using common sense. Now, I gave you a video earlier of how to upload these graphs using Desmos so that you wouldn't have to do it by hand. I'll show you real quick how to do that once again. You click this share button right here up above the green sign, right beside the green sign up button, and you get these options right here. You need to select export image, then download the PNG file. You can change the size of it, but you don't have to. It will download it onto your Chromebook or your computer. And I can't exactly show you on this. You'll have to go to the other video for specifics. You will click this add file button, and it will bring up an option to upload a file. And then you will need to select a file from your device, go to wherever the file downloaded, and choose the correct graph, which should be the last one that you downloaded. You can do this for all of the graphs that you need to upload. Once again, if you have any questions, please email me. My email address is cdtraywick, Traywick, @chiltonboe.com. I hope this video has helped, and I hope you also have a good day. Thank you.